going to the general Q&A session, where you have the opportunity once more to direct questions to all of the speakers we had this morning. Remember, though, to focus your questions mostly on the applications, so tank to wheel, tank to propeller. We will cover the production of methanol or other e-fuels extensively in the afternoon. So now it's more about applications using these fuels. So we will get started with a number of questions that we didn't come round to answering this morning. But in the meantime, feel free to add additional questions on Menti. So let's see what we'll have first. Maybe one that we didn't come round to for Mats when we were talking about the fuel cell systems. You mentioned the reformer and the lead-up time that you need for that. I don't think you quantified the startup time. Could you share some insights there?
Yes, I can. So we name the startup time on a system level. Mm-hmm. So this is 10 minutes, and this is something where we, by using a hybridized approach, we don't have to speed it up, because we have the battery as a sort of as a bridge. It could easily be down to 5 or less, but it always is a compromise. So if you do the thermal expansions from 0 to 160 on the materials that we use, it has an impact. So the reformer itself, I would say, could do it much faster if required.
Yeah. So 5 to 10 minutes, then you can make do with relatively small battery sizes.
Yes.
Okay. Then I'll very selfishly take a question myself, a question that came in on explaining what engine options we're looking into with the fast water projects. So that spans a range of engines, and there's 2 parallel tracks there. One track is focused on the demos, on the vessels that we will clock sailing hours on. Of course, there we're targeting engine technologies with a higher technology readiness level. So for a high speed as well as for the medium speed engine, we're looking at dual fuel solutions, so with a pilot injection of diesel and the methanol then being introduced in the intake ports. That is a convenient way allowing to retrofit engines. That's one technology. Another technology is the MD95 concept that was also explained in a bit more detail this morning. So that's a single fuel solution then. That's an engine that can then only operate on MD95, so 95% methanol, the rest being ignition improver. Then parallel to that, we have a work package looking into next generation methanol engines, where now we're having to make do with what is easily available and what is acceptable to current vessels. We also want to be able to look into or get data on what is feasible with dedicated methanol engines. If we can really tune an engine to make best use of methanol's properties, what is going to be the efficiency potential? So one of the things we're going to look at is the PPC type concept that Professor Martin Tuner was mentioning. So compression ignition operation on pure methanol, see what's feasible in terms of peak efficiency and emissions there. On the other hand, we also want to see the potential of spark ignition concepts. So we want to map out the engine map or the engine range, power range that is going to be feasible up to medium speed engines with a spark ignition concept. Then I'll take the next question. That's targeted on MD95. So I guess I will target that maybe to Martin. So the question there is on whether that will remove the need for a pilot fuel or a spark. Would it be the way forward, this MD95 concept? What do you think about the possibility of that? I'll ask Martin up here.
So thank you. Yeah, I think that's, since it's already a commercialized concept, it's for sure that should be used initially, and maybe that's a good way for a long time. So, yeah.
And do you see limitations in terms of engine sizes? Would it apply to every type of engine principally?
I don't think it should be too much of a problem even for larger engine sizes, but we have not investigated that, so I would be slightly hesitant to give a solid answer there.
Yeah. So again, stay tuned. That's a concept that we will look into also within the fast water project. Thank you, Martin.
Thank you.
Then we have a question that is a bit more big picture. I think maybe I will direct that to Eelco. A question on whether it wouldn't be more efficient if you produce biomethane to feed that into the gas grids instead of converting that biomethane into methanol.
It's a question we often receive, as I try to say, as far as I'm concerned, and that may sound strange as a proponent of methanol, but any means of displacing fossil energy with renewable energy, I personally favor. So I have absolutely no problem in terms of using renewable electricity to produce methane. However, what I have been explained by those that understand chemistry and those that understand engineering, producing methane from renewable electricity actually requires about 1/3 more hydrogen, because the Sabatier process actually produces a lot more water than the methanol process does. So depending where you come from, whether your limiting factor is energy or whether your limiting factor is carbon, you are able to produce more methanol with the same amount of hydrogen, or you need more hydrogen with the same amount of carbon. Yeah. So from that perspective, certainly if renewable energy is the limiting factor, I think that producing methanol makes a lot more sense. Also purely from a transportation perspective, as Mr. Saanen explained in this presentation, if I convert renewable electricity into methane and I want then to use it as LNG, I still need to waste more energy to make it liquid to actually get it on board of a vessel. Yeah. So it doesn't stop at the conversion from electricity to methane, but you also have to look at the total energy balance.
Yeah, thank you. And then I'll just stay with you for a short while with the next question that I would actually like to hand out to various speakers. And the question is, what other alternative fuel do you see as the greatest threat to methanol? So I'll start with you, Eelco.
Well, personally, I don't think it's so much about threat. I think if I look at the challenge that we face as a society to move away from fossil energy, as I said before, I welcome any alternative that can displace fossil energy. So I think that is the key message. To build on this question that you just raised about methane, I think methane and methanol, depending on the specific use application, can be complementary. I also think that it would be wrong to look at synthetic fuels only, but I think there's a lot of synergy between biogenic pathways and renewable pathways or synthetic pathways. I guess, if anything, if somebody breaks the biggest challenge for storing and transporting pure hydrogen as such, maybe the one thing that could potentially be the biggest challenger to methanol as a hydrogen carrier would be neat hydrogen. But for the time being, I think methanol still makes a lot of sense for a lot of practical and economic reasons.
Okay, I'll take that ball concerning hydrogen and maybe throw it at Mats. If you're working on methanol fuel cells, you must face some stiff competition with hydrogen. So, do you see hydrogen as the greatest threat to your methanol technology?
No, not really. Mm-hmm. I mean, it's clear that when you look at it in a total perspective, I think it becomes clear what's the comparative case. If you look at it individually on specific cherry picking elements, then there are some advantages. That's clear. But I think at the end of the day, it comes out to being a matter of what's feasible for the operators to actually implement.
Yeah, the best match.
Yeah, and I think, if you somehow see the benefits of hydrogen and you can get the infrastructure up and going, get some renewable hydrogen supplied somehow at a good price and so on, then that's fine. It will be great. Methanol will have some other areas to be competitive in.
Yeah, thanks. Yeah, many applications out there with many different requirements, I guess. But maybe I'll throw that once more, and maybe at Daniel. Do you see another fuel as a threat to methanol?
No, I would really like to turn that question into the opposite. Mm-hmm. As Elko mentioned before, every renewable fuel, every renewable energy that is used is a good energy, and this is something that really concerns me, that we see this heavy competition of the different renewable energy carriers or different renewable fuels fighting against each other, and by that we are often forgetting that the common enemy is the cheap fossil fuel.
Absolutely.
And as long as that fuel stays so cheap, there will be no uptake, because it is so simply as that. The company using renewable fuel, which will cost more, is the other day bankrupt, and that's it.
Okay, thank you. Then we have a question which is sort of on the verge between morning and afternoon session, between production and use, that I think maybe I'll first direct to Sheld. It's on, well, if you look at synthetic methanol or e-methanol versus fossil methanol, of course the molecule is the same thing. So I guess you could broaden that question to any type of e-fuels. Do you have any ideas on how to avoid fraud, basically, from fuel leaving the production sites versus fuel sold to the ship? Who will decide on any carbon credits to be assigned? Are there ideas on that out there? Do we have Sheld still in the call?
Sebastian, I don't know whether we still have killed, but maybe if you allow me to, at least from our perspective, from what we hear from the politicians,
definitely,
to comment on that. This whole discussion about accountability of the carbon saving, and especially when you deal with point sources of CO2 from industry, is a very hot topic and probably a hot potato in the political debate. The general consensus in Brussels right now is that the industry that is the source of the CO2 will continue to be seen as the emitter of CO2 from an ETS perspective. So if we take the example of a steel mill, if that emits CO2, and that CO2 in the future is captured to be converted into a synthetic fuel, an e-methanol, for example, that steel mill would still have to pay for its CO2 emission rights under ETS. Mm-hmm. And the e-fuel, the synthetic methanol, would basically qualify as a carbon neutral fuel. That's the current political view. But obviously, if you're a steel producer, then there's little incentive unless you get some of that money you pay for ETS back through the value of the e-fuel.
Thanks. Then maybe another question for Daniel concerning safety again. I know you have quite a bit of experience there. There's questions up there concerning venting of the methanol vapors, especially if you need this extraction, as you mentioned earlier on. So can you give us some ideas of what comes into play there? Is it very different from in terms of ship design?
Yeah, maybe I started a little broader view. So what we have realized during the development of the methanol interim guidelines at IMO is that many things came from the more sophisticated LNG level down, and this is actually a mistake that was because methanol, since it's a pressureless liquid, as diesel, as other liquid fuels, the other way around would have worked much better coming from diesel fuel, and then addressing the properties that it is a low flash point fuel, and that it vapors out, and so on. And that would have, and we're still fighting to address these issues at several occasions. And I can only also have a plea to the audience to always question whether certain demands that maybe see coming, look more coming from LNG, to question these with your authorities.
Thanks. Then maybe a question for Bert at DEME. Can you see where technology providers are still missing? You have plans, you're comparing different alternatives. What are for you currently bottlenecks to go to try out alternatives?
Well, it's basically just the market demand for engines, and that then in turn is determined by the market demand for the fuel. And it's been said by the other speakers as well. As long as the fossil fuel stays cheap, there will not be a next step. And that's also good news, because it means on the technical side we don't see much barriers.
Yeah. Okay, thanks. Then maybe another one for Eelco. You might have some ideas on that. Okay, we have the MAN two-strokes out there that power methanol tankers. What about converting inland barges transporting methanol? Any idea of how many of those are out there? Are they all very similar in nature? Would that be a good move to try to start converting those engines to be able to run on the fuel that they're transporting?
If I'm not mistaken, there's a clear synergy between the fast water project and some of the engines that could potentially be used in inland waterways as well. So it's a good example of a project that is looking exactly at this type of application. But yes, short answer is we are working with a number of companies to look at the conversion of inland waterways. It's an industry that has its own challenges, where for a number of reasons, LNG hasn't made the same kind of successful entrance as on the seagoing vessels. So we are currently exploring with a number of companies, both ship owners as well as engine providers and fuel blenders, how we could accelerate the uptake of the use of methanol for inland waterways. But yes, we do see short-term benefits, not only in Europe, where we're looking at potential projects in China and India as well.
Yeah. Any idea on the number out there for barges transporting methanol?
Not off the top of my head. I'd have to go back, but the interesting thing here is that we are looking well beyond the scope of only converting those barges that carry methanol as a cargo. We are specifically looking at ways of converting other vessels that are currently not exposed to methanol as a cargo, but rather either on the river cruises, for example, but also for dry bulk and other applications. We're certainly looking at possibilities.
Yeah, great. Thank you very much. Martin, can I ask you up here again for maybe a question on emissions? I think it was on one of Bert's slides that one of the potential drawbacks could be formaldehyde emissions. What's your take on that?
Formaldehyde emissions, that is very much related to the hydrocarbon emissions that you get, and those are depending on the fuel preparation inside the combustion chamber. So port fuel injection, for instance, is easily leading up to increased aldehyde emissions. So with direct injection technologies, the risks are lower for this type of emissions. I think that's the answer.
that's the engine out part of that. Do you have any idea on how to treat for formaldehyde? Is that a challenging thing to do?
No, not at all. I mean, by using an oxidizing catalyst, the formaldehyde emissions are usually very easy to break down.
Yeah, so no deal breaker.
Not really.
Okay, thank you, Martin.
Thank you.
We have a very wide-ranging question now on what the first important steps would be towards using methanol as a sustainable energy carrier. So I think I'll throw that to a number of you. Maybe, well, I have Daniel here on the screen. Maybe Daniel could have a first stab at that.
Sorry, Sebastian, what was the question?
So what the first important steps should be towards enabling the use of methanol as a sustainable energy carrier?
I think, as I said numerous times already, I think the most important thing is that market-based measures come into force, that we get something like emission trading system running, maybe even fuel quota, carbon pricing, and so on. But then I think a further important is that actors, of course, I can mainly speak for the marine application, for the marine field, but that actors realize that methanol has this drop-in capability. You cannot immediately drop in that, of course, but you can utilize to a big extent the diesel tanks or heavy fuel oil tanks that are existing in ships. Actually, you can even make them bigger when going to the side or to the ground of the ship, compensating a little for the disadvantage with the energy density. So I think realizing this, that the drop-in capability is there would be a good step. Yeah,
I'll pick up that question later on again, but we have another question that was directed also at you, Daniel. So okay. I'll take that first. If you could share the findings with the fuel cell systems that you have experience with.
Yes, of course, absolutely. So the major advantage that the fuel cell system gives us is actually not so much the increase of efficiency, what is always widely spread. This is not so much the thing. The more important aspect of fuel cells is that we are able to build the ship up in a completely another way. So to change the layout of the cruise ship completely, because fuel cell applications allow for small energy units that are placed around the ship, and so you will not, in the far future, you will not need these heavy trunks in the middle of the ship that steals a lot of space from you. You're more redundant placing these energy units on the ship, and so there for us is the main advantage. Yeah. Of course, also an aspect is that we get rid of all the pollutant emissions, as it was said by Mats already. But one should not forget, considering fuel cells, and that is often forgotten, that we need an energy carrier, and this needs to fulfill certain aspects. And presumably the best thing is that it's liquid in natural state.
Okay, thanks, Daniel. Then coming back maybe to the first important steps, Gert, maybe I'd like to ask your opinion on that. Where do you think we need the first steps to realize methanol, or to realize the more widespread use of methanol as fuel?
Yeah, I basically agree with the first with the comment from Mr. Saan, that the policies will heavily affect the pace of which any alternative fuel eventually can be taken up. Market-based measures, especially carbon tax, can be really a game changer in that it can bridge the gap, especially economically.
Absolutely, yeah.
Then being more into the domain of technical, I believe engines, and especially dual fuel engines, as long as the availability is not widespread, giving fuel flexibility to vessel owners might be one of the first steps to take.
Thanks. Then maybe another fuel cell question, so maybe for Mats. I don't know if the questioner is referring to an EMSA study on the use of fuel cells in shipping, safer, smarter, greener. I don't know if you know that study, but apparently it states an efficiency of 20% for a DMFC, whereas you have shown much higher efficiency. Can you, first of all, do you know the study, or can you imagine how they come up with 20%? Is that looking at a wider part of the picture? Other things involved there?
DMFC, so direct methanol fuel cell. This is a different type. What we're doing here is a reformed methanol fuel cell, so RMFC.
Yeah.
So what they could be referring to is the type of fuel cell where you put methanol directly onto the membrane in a water solution. Yeah. So this is very well-known technology. Is actually also in the maritime area, but for very small power ranges, below 1 kilowatt. So very successful implementation of the methanol fuel cell. Actually more than 45,000 generator sets sold over the last 10 years. So, but small power.
Yeah.
So,
but do they really suffer from? Do they really suffer from a lower efficiency, or how do they fare in terms of efficiency?
Yes, they do. That is a low efficiency technology. Yeah.
Yeah. So it's another type of fuel cell technology. Okay. Yeah. Then maybe I'll come back to Eelco. We have a question on methanol fuel standards. So there's a chemical grade methanol standard out there. There's work underway to look into fuel standards. Could you update us on the status there?
It is correct. There's a couple of things happening. There's at the same time also a lot of confusion around what is meant with the methanol fuel standard, because obviously you have the specification for methanol as a product, as a neat product, which currently globally is being traded against the IMPCA specification, so International Methanol Producers and Consumers Association specification. And that product by itself is a very high purity product, which is over 99.9% purity. So there's basically nothing else in there but methanol. I guess that there's currently two important developments in terms of specification. I know that some of the producers or some of the projects that are looking at developing renewable methanol pathways are arguing that for certain types of fuel applications, there is no need to distill the product. So I've heard words like crude or undistilled methanol, which typically contains primarily a lot of water and a few other carbon chains, some other alcohols in there, which is true. It can be used to run ship engines, for example. So if there is enough benefit to skip the distilling step to use it in engines, then potentially it makes sense to develop a specification around that type of fuel. But there are some challenges around that as well, because today methanol is a global commodity. So that means in the current storage, a lot of the methanol is being commingled because there is no difference. If I have a second methanol spec, then I would also have to set up a separate logistic chain for that to store it and distribute it. Yeah. So there are some benefits, but the question is whether those benefits outweigh the disadvantages in having to set up a whole new distribution system. One of the big benefits of methanol today that is already available in all the major ports. So that's more a commercial question. Yeah. And on the specification side of things as well, we actually, in Sweden, we're now investigating the possibility of a standard for dry brake systems for refueling. In Germany, we have a working group that is looking specifically at methanol fuel specifications, not just for the neat methanol, but also for things like high blends. China already has an M15 standard. And we're actually currently exploring with SEN whether there is a need for a methanol fuel standard. So there's a lot happening in
great. Yeah.
that area.
Thank you very much, Eelco. Then I
Pleasure.
think I'll take one more question, and I'll take that myself. The question is, well, if you look like methanol, it looks pretty similar to gasoline in terms of operation, whereas most of the application we've focused on this morning, heavy duty transport or shipping, those are more diesel-like. So how to explain this? So I think that's a good question indeed. I think there's various aspects to that. On the one hand, it's about where the market demand currently is. So I've explained the background for why shipping started looking into methanol in the first place. These upcoming legislations we had a few years back on SOx and NOx emissions. Then methanol surfaced as a potential interesting option there. But there, of course, the challenge is, well, those types of applications run compression ignition engines. So hence the difficulty technology-wise of introducing methanol there. A second aspect of that is, well, the market demand too, but then more the lack of demand from gasoline engine type applications, which is passenger cars. If you look at the European level, there's a very large drive there towards electrification now, for partly at least for good reasons. So it's a much more difficult market there. The main thing that we see moving in terms of applying methanol to spark ignition engines, gasoline type engines, is actually in China, where as Eelco mentioned, we have 20,000 taxis operating on methanol there. And then Martin, you're signaling me. Do you want to add on to this, or?
I would like to add to that. I mean, it's so much down to operational costs, and looking at the price of heavy fuel oil in comparison to gasoline, of course, it makes a case for diesel engine technology. But methanol is methanol, so it doesn't really matter which engine technology it is, as long as it is the most efficient and clean one. So, and with a very quick development of very efficient spark-ignited engines, that could well be the most economical case for the future.
Okay, thanks, Martin. And with that, I think I'll wrap up this morning session. Thank you to all of you for listening in, for sharing your questions, and I hope all of you will be back at 1:15 when we pick up the discussion again and start looking into the production side of things. So be back with you 1:15.